Hi, I'm Sarah, and before we go to building this circuit, I'm going to talk to you guys a little bit about the theory behind a full wave bridge rectifier with a smoothing capacitor. So the main purpose of a full wave bridge rectifier is to take an alternating current input voltage, so an input voltage that is a sine wave, and use diodes and capacitors and some sort of load, which in this case is a resistor, and produce an output that is a nearly perfect DC voltage that only fluctuates very, very slightly. So the first of the two components that the rectifier uses to create a DC output voltage from an AC input is a diode. And diodes are components that have an anode and a cathode, and current will only flow from the anode to the cathode. What the diodes do is they make the output voltage greater than or equal to 0. And so the output voltage without the capacitor would look almost like the track of a bouncy ball going across the room in a cartoon. So this is just a diagram showing where current can travel through the diodes based on whether the input voltage sine wave is positive or negative. These diagrams, I think, are the most helpful for me in kind of reminding me why we care, or why I would even bother building this circuit. They really show how you can take a completely alternating current sinusoidal input voltage and create an almost perfect DC output just using diodes and a capacitor.
Hi, I'm Ramessa, and I will be showing you how to build a full wave rectifier. To make a full wave rectifier, we need to start with a diode. Notice that the diode has a mark on one side. This indicates which way the diode should face. Before we start putting diodes into our circuit, we need to have an input which is shown with a red wire. Next, we will place a resistor to stabilize our circuit. After this, we will place our first diode facing the resistor. The first diode that we will add is D1 and is shown in the circuit diagram. The next diode that we will add will be D2 facing away from the resistor. We will continue adding diodes until the loop is completed. Next, we will place a black wire to indicate the ground of V in. In order to fit the full wave rectifier, we added a jumper to connect the two breadboards. Next, we added a resistor and a capacitor in parallel. In order to have the resistor and capacitor in parallel, we added a jumper from the capacitor to the resistor. Next, we connected the resistor and capacitor back into the diode loop. Finally, we added wires for a Vout or load. This is the end result of our circuit in all its glory.